Good morning, good afternoon, and good evening, everyone. I'm Rob Meyer. I run outbound product management here at GridGain. We are going to begin in just a couple of moments, but first I wanted to make sure you know your way around the screen and know the details of how we run these in-memory computing best practice sessions. So first, please raise your hand. It's located in the go to webinar meeting. You should see a little hand button. I just want to make sure that you can hear us. So I did see a couple hands going up, so perfect. Thank you. So during the webinar, you're going to be on mute, but if you have any questions during the discussion, I am going to be watching the question and chat session area. So feel free to post your questions. I will be answering some of them throughout the webinar, but I am going to be saving the hardest ones for Dennis Mahanikov, who we will introduce in just a moment. But first, an introduction to the topic. We've been running a series on moving Ignite into production. One of the topics, of course, is always going to be around monitoring. So Dennis, who is part of our customer SWAT team, he's an engineer who helps with some of the hardest deployments. Dennis is a contributor, but of course he also works a lot on these hard problems and knows a lot about monitoring. So we thought we'd have Dennis give some of the best practices today for monitoring Ignite and also monitoring GridGain clusters. So if you're familiar with GridGain, if you're just familiar with Ignite, GridGain originally contributed the code to the Apache Ignite project. We continue to be a leading contributor, including folks like Dennis who work on various parts of the project. So we also have the only commercially supported release, but we support Ignite and provide services for Ignite as well. So we get involved in many Ignite projects as well. With that, I figure I will turn it over now to Dennis, and we can move through the webinar. But please, throughout the webinar, feel free to ask any questions during the webinar, and I will try to answer some of them and save the hardest ones for Dennis. So Dennis, it is all yours.
Okay, thanks, Rob. Well, as Rob already said, my name is Dennis. I work at Customer Solutions team in GridGain. And during our work, my team and I work with environments of our customers with their installations of distributed systems. So we have some insight and knowledge of what these distributed systems look like, how they are monitored, and what is the tooling that is usually used there. And I can tell that there is quite often a huge gap in monitoring, in logging, and it can be easily covered by just following a few straightforward steps, and by doing so, you're going to improve your experience with your distributed system and make debugging and overall work much easier by just having more information about your system. You're going to need to do it just once, and after that your work will be easier and debugging will become much faster. The solutions of the problems are going to be found much easier, and the delay between the issue first happening and the solution will be like much less. So let's start by looking at the problem, and we'll start with motivation. After that, we'll see what kind of approaches can be taken for any distributed system, and after that we will go to specifics of GridGain, and at the end we will have a live demo. So the motivation. Let's imagine that we work at customer support, and a customer comes to us and he has some kind of problem. For example, he has a honey cluster, so the requests are coming to the cluster, but it doesn't get any response. So the customer tells us that the cluster is hanging, and to start some kind of work, we need some information, and the most useful part of it is logs. So we ask for logs, and believe me or not, but sometimes even logs are not available because people sometimes don't know where they are stored and how to change the log level. Usually this is the kind of thing that everybody configures, but sometimes even that is not available. So if we don't have any, then we try to find some different kind of source of information. For example, if it's a hanging transaction or something, we're going to see it in thread dump. Maybe there is a deadlock on the JVM level or something like that. So we ask, do you have thread dumps? Well, people sometimes don't know the procedures. They don't have special procedures to collect thread dumps from the whole cluster, and well, sometimes the installations don't have special tooling. For example, if you install only JDK, not only runtime environment and not the JDK, you're not going to have special tools to collecting thread dumps. And yeah, sometimes we end up without even thread dumps. And after that, if we don't have anything, we start guessing. Well, maybe the issue is high memory consumption, and the problem is in garbage collection. So we ask for something like that. So this kind of ping pong goes till the point when we either have some information to work with, or we configure additional monitoring and after that wait for the issue to happen again when we're going to have some evidence and to be able to tell what happened and to prevent it. So this is this unnecessary delay between this issue happening and the start of some work, some kind of analysis. This is really unnecessary and can be eliminated by just configuring monitoring in advance. That will give you more information in future if something bad happens again. So let's start and see what we want from our tools and or what kind of issues we want to solve by configuring them. First of all, you'd like to look at some kind of dashboard and tell if your system is fine and if operations are running and if it's doing all right. Also, you'd like to see if any kind of issue is coming, if it's going to happen. And if something has already happened, then you want to know about it to react and to just bring back the working the system into a working state. These are the kind of tasks that are solved by configuring dashboarding. Another kind of thing is logging that is storing some information in some centralized storage, or not centralized, but storing some historical data which will be useful when an issue happens and you want to analyze it to tell what happened and to determine if it's some kind of bug or something, and to prevent it from happening again. So let's look what are the specifics of a distributed system that we can take into account while configuring the appropriate dashboarding or logging. So any distributed system is a set of nodes and connections between them. Well, if you make sure that every node is working and the connections between them work. It doesn't mean yet that the system as a whole will work fine. So you need to make sure that the system, the business operations are also working. So you can take a black box approach and pretend to be like a user and send some synthetic requests to your system and see if the responses are coming back. Let's look what every node is. It's like a set of layers. On the lowest level, there is a hardware, or it's a hypervisor if you work in a virtualized environment. On top of that, there is an operating system. Sometimes you have virtual machine. It's quite often to have some kind of virtual machine. If you have Java, .NET, Python application, then you have some kind of virtual machine, and this is a pretty common thing. And on top of things, there is an application. And if you have some kind of issue on a lower level, for example, if you have not enough resources on a hardware level, then there's no chance that you're going to have your application working. If you or if your network is not working, then your distributed system won't work either. So you need to make sure that all of the levels are fine, and only then your system will be working. Usually network is monitored on the lowest level on the as a hardware, and the black box approach is taken on the application level. So we will look at it in this separation. So let's start with hardware or operating system. Usually these are the things that are monitored together. We want from hardware the basic resources like CPU, memory, and disk, and we want to know when there is not enough of them and when we need to add more. So this is a kind of thing that you almost always need to monitor and track, and if there is not enough, then to add more or make something with it. Also, usually there is a system log available, and you don't always need to keep it for a long time, but in some cases it turns out to be useful. So you may want to look at it in some cases. For example, in our practice, there was a case when a Java application was running and it didn't show any signs of any issues, like the memory consumption level was fine, and there weren't any GC pauses, but at some point the application just quit and it didn't even finish the log line. And we found a reason for that in logs of out-of-memory killer that at some point decided that the process, the JVM, consumed too much memory and decided to just to kill the process and to free up some memory. So sometimes this kind of data is useful, and it's good to know where it is stored and where to look in case it's needed. Also, if you have a cloud provider, then usually it gives you logs that you may also look at. On the hardware level, also usually network is monitored, and here you can take different approaches. For example, you can set up a set of pin agents that will track each other and look after each other and tell you when if there is a link that is broken or or when it's a latency spike that you can find by just sending the small requests between these agents. this is pretty convenient in a distributed system because you can correlate issues in network with other problems, and this is a kind of thing that turn out to be useful pretty often. Another thing, if you control your environment and you control your hardware, you can use special software for your network hardware and monitor it this way. Just to go to a vendor of your hardware and take a special soft for it. And if things go wrong and you know how to reproduce it, and you want to look what kind of messages are sent between nodes, then you can take a TCP dump and see if what kind of data is going between nodes. So this is a kind of thing that is which is hard to analyze, but sometimes it's useful. For example, we usually take this approach while finding the reason for some slowness. If you want to distinguish whether a client or a server is slow, you can take a TCP dump and see the difference between the timestamps of a request coming to a server and the response going back. So if the server is slow, then the biggest part will be spent on the server side. The advantage of it is that you don't need to add any code, and it gives you like the good approximation of how much time is spent on the server side. So sometimes this approach is good. On top of operating system, there is usually a virtual machine, and every virtual machine has its own set of metrics and approaches how to monitor it and debug. And in case of a Java virtual machine, a very important part of its work is garbage collection. And you would like to know when it's a network issue or a garbage collection, because garbage collection is the thing that is hardly distinguished from the network issue, because it's hard to tell whether a link is broken or nobody is answering on the other side. So if an application is sleeping while collecting garbage, then it won't be able to send any response to the other side. So you would like to configure logging of garbage collector pauses, and we usually recommend it enabling on any production system because it's quite often pretty useful. Also, there is an interface for metrics and management called Java Management Extensions, and you can take a look at pretty important metrics such as memory consumption level and garbage collections and like loaded classes and things like this, and sometimes it turned out to be pretty useful. Also, there is a tool called Java Flight Recorder, which is available in Oracle JDK or any JDK starting from version 11. And it provides a capability to record a snapshot of work of your application and see what are the hot methods, what is the level of memory consumption. It also collects thread dumps, and you can find a reason for slowness of your application if you're looking into performance issue by looking at the JFR. Also, if you're investigating some kind of a deadlock, then you can take a thread dump, or if you have a memory leak, then a heap dump can be useful. And if you have some kind of heap dump memory leak, I mean, then at some point you're going to have an out of memory error. And when people come to support and say that they experienced out of memory error, we usually ask to send us a heap dump. But if your application has already failed, you can't collect any kind of heap dump or collect any information because your application is already down, and you need to enable a flag or something to make the issue reproduce again to gather the evidence once it reproduces. So instead of making the issue happen again, you may configure the flag. For example, in Java, there is a heap dump on out of memory error flag that collects the heap dump when memory comes to end, and you'll be able to look what is the issue, where is the memory leak, and identify how to fix it. And on the highest level, there is an application, and it knows best when it's something wrong with it. So logs is the most important thing among all the information available about your system. So please make sure that you have logs enabled on an appropriate level and you know where they are stored. And in case if you need them, then you have access to them. This is really important, and you would like to always have them available. Also, you can use the same interface that you use to monitor Java. You can use JMX to expose metrics about your application, and use the management capabilities to do something with your application. And if you want to take the black box approach, you can measure throughput and latency of requests that are coming to your system, or you can generate synthetic requests and see how they are processed and what is the metrics, and if they return correct responses that you expect. So to this point, we have reviewed some approaches and general ideas how to monitor just any distributed system. So now let's look what are how to implement these ideas and what are the tools that can be used for it. Let's start with metrics and some values that can be stored as time series. For these things, Prometheus and Grafana are used together usually. Prometheus is data storage with its own query language, and Grafana is a thing that can be used for creating dashboards. So you can send data about your application, your metrics to Prometheus, and it will keep your data in case you need it in future, and configure plots and dashboards in Grafana. So you solve like two problems at once, logging and dashboarding. If you need to analyze textual information, such as logs, then you can use either a connection between Elasticsearch, Logstash, and Kibana, which is free, or an enterprise product, Splunk, which is like more powerful, but it costs quite a lot. So Elasticsearch, Logstash, and Kibana are pretty commonly used, and this is more convenient than just looking at logs by hand as text files, because you can perform some automatic analysis on the fly and generate alerts if something goes wrong. If you find a message in logs of a certain certain pattern, and you can generate messages to responsible people if you find some errors in your logs, and this is the thing that can be done on the fly. Also, for any virtual machine, there is a set of tools that can be also used. I already mentioned the flight recorder, which is pretty useful and powerful. Also, there are other applications like Visual VM, JProfiler that can be used, but in GridGain we usually use flight recorder because it's available everywhere almost, and almost every customer has it. So you can just enable a few flags for your JVM, and the flight recording will be saved. And for analysis of your garbage collector logs, it's pretty convenient to have some kind of visual information. And to generate it, you can use, for example, a GC Easy website that can take your garbage collector logs and generate plots of memory consumption and moments when garbage collections were performed, and this is more convenient than just looking at textual data generated by your virtual machine. And if you want to analyze a heap dump, you can use an Eclipse memory analyzer called MAT that can perform some basic analysis like to build a dominators tree or show leak suspects, and you can use it to identify some problematic places. For network, there is a special set of tools that can be also used. For example, you can use Zabbix that can be used not only for network monitoring, but for network. There are special capabilities. It can work over SMTP or SNMP protocol and collect information about the hardware in your system. So you can use something like this, or you can go to your vendor and take special soft. For example, if you have Cisco routers in your system, then you can. There is a big set of special tools provided by Cisco, so you can ask them for special software. You can use SolarWinds to set up a set of PIN agents that will tell you where latency spikes in network. And in case if you have some network outage, then you'll be able to identify it using SolarWinds. And to look at TCP dumps, we usually use Wireshark. Also, I would like to mention benchmarking. For GridGain, usually Yardstick, JMeter, or Gatlin are used. The most popular one is JMeter, but there is an issue with it because the usual pattern for it is to set up a distributed system, web server, and the application that is measuring the performance of the distributed system. So sometimes when we saw this pattern, we saw that the performance is not that good, is not that high as we expected, and we decided just to remove all the business logic from processing from the benchmark, and it turned out that the performance was the same. So without any business logic, the performance of benchmarking is the same as with business logic. And the bottleneck turned out to be in the web server that is proxying requests into the distributed system. So when you use something like this, you may encounter issues with bottleneck being not where you expect it to be. So if you decide to use something developed specially for distributed systems, then you can use, for example, Yardstick, which is developed inside GridGain and has some capabilities especially for distributed systems written in Java. And you can use it not only for Ignite or GridGain, but for any distributed system. And for Ignite, there is a set of benchmarks which are tracked between releases, and you can go there and use them for benchmarking your setup of your distributed system. A report generated by Yardstick looks something like this. You can specify what kind of benchmarks you want to run, and Yardstick will set up a cluster, warm it up, and measure the parameters that you wanted to measure, like throughput and latency are the most common ones, or you can measure the CPU utilization or disk utilization or network, and you'll be able to see it on all in the report on the same plot. So this is a report that I generated recently, and you can see here that on the throughput plot there are three places where nothing was processed, and it's most probably a garbage collection. So we might want to configure the garbage collection properly or increase the memory consumption. Okay, so let's go and review some specifics of GridGain. And GridGain is everything that I was talking about previously can be also applied to GridGain, but the specifics is only on the highest level, where because there is a special application that we can take specifics of this application into account and look at some specific metrics that it reports to track health of the whole system. And we have all the same, like we have JVM, OS, and hardware, but there is something special on top of things. And the centralized, like the main thing in GridGain, main concept is the cache, and we have a special set of metrics for it. You can see how many get operations were performed, how many puts, how many removes, and you can see the throughput and latency of these operations, what is the average time of different kind of operations, or you can see if any processes are happening in the cluster. For example, you can track rebalancing by looking at cache group metrics, and tell when partitions are moving between nodes, and if it's safe to stop nodes, or you should better wait for the rebalancing to finish. These kinds of metrics can be enabled in the configuration. For cache, there is a parameter statistics enabled, which enables the metrics. In GridGain, there are two kinds of transport: discovery and communication, and this is like the basis for the whole system, and you can track it also using the JMX metrics. You can check the queue sizes and average processing times, and see some additional information that can be useful to track health of your system. Also, starting from Ignite version 2, there is a data storage feature which allows you to store more data than you have RAM available. So you can the Ignite can use disk storage to dump some pages of data, and in case if a node crashes, then it can recover its state from the data on disk. So there is a subset of data stored in RAM, and the full set of data written to disk. There's also write-ahead lock, which is used for recovery, and for data storage, we also have a set of metrics that can be tracked. For example, you can check what is the data volume occupied by everything on disk, and you can see what parts of it takes most time, and per every data region you can also see what is the allocation rate of pages, what is the fill factor, and you can track both performance and the data volume using these metrics. There are also specific processes that happen related to data storage in GridGain. For example, one of them is checkpoint, when the state is synchronized between memory and disk, and this is a kind of thing that can affect work and performance of your application. So you may want to track it in case if you have some performance issues, because if you have too many checkpoints, then your performance will be limited by speed of your disk, and you may want to increase the size of your memory region, for example. There is a set of metrics that you can use for it. Like you can see how many modified pages, and you can tell if a checkpoint is going to happen soon, and you can track what is usual time of checkpoint. So there are some useful metrics that you can take into account. Also, there is a pretty important procedure called page replacement, and it happens when you need to perform an operation on a page that is currently not stored in memory, but you need to go to disk and preload some page to memory, and to do so you need to remove some existing page on memory, because you may not have enough memory to store another page. And if this procedure happens too often, and you need to remove some pages and read others, then your performance again will be limited by speed of your disk, and you won't get any advantage of the fact that you're using an in-memory solution. So to track this, we also have a set of metrics available in JMix. These kinds of metrics are can be enabled in configuration in corresponding properties. Also, it's planned to include into Ignite 2.8 additional metrics that will show how many pages were accessed during work of a node, and how many index pages, and how many logical operations led to physical operations that went to disk, and based on it you can find issues with page replacement, and you can identify some improper configuration. For example, if you specify wrong inline size parameter, you may find that you pretty often go to disk, and it can be a signal for some issue that needs to be identified. And for GridGain, we have a dashboard, a special tool that has a pre-configured set of metrics available out of the box, so you don't have to spend much time configuring it, and you can just install it and use a pre-configured set. There is also available set of management tools, so you can use it to change the state of your cluster, and in case if you need to change something there is also available tools. So let's look at capabilities of WebConsole first. I prepared the cluster with 3 nodes that have persistence enabled. And so you can see that 3 of them are started, and there is also a web agent that is working next to them. The web agent is a thing that connects your cluster to WebConsole, so you don't need a WebConsole to be installed next to your cluster. In this demo, I will use a cluster running on my laptop and WebConsole installed on our website, console GridGain.com. So here is WebConsole dashboard. Now we can see that the cluster is inactive. It's not activated because the persistence is enabled, and like nothing happens there. We can use this switch to enable it, and after that we can start operations on it. Also, I configured Elasticsearch, Logstash, and Kibana especially for this cluster, and I configured it in such a way that logs are not written into files, but instead they're sent to Logstash, and it parses logs, and you can see it in Kibana. And I have logs for all 3 nodes here. You can switch between them, and you can use capabilities of Elasticsearch to find information matching some pattern. For example, if you want to know the history of topology changes, you can look for topology snapshot. And you will see when topology was changed and what is the history of these changes. Or, for example, you may want to look at operations happening in some specific thread or some component, and you may filter out the information related only to it. It's more useful and convenient than just looking at text files, because here you may parse logs, and the filtering happens on a record level, not just line by line. So it's like if your log record takes several lines, then you filter the whole record instead of a single line. And you may use capabilities of Elasticsearch and do more advanced analysis. So let's go back to WebConsole, and not to look just at flat plots, I prepared also an application that generates some load on our cluster. And what it does, it calculates the number of dividers that every number starting from 1 to infinity has, and it sends a compute task. Let's look at the task. It divides the work of checking the divisibility of a number by numbers that less than them. The parameter number is the number that we want to check, and the work is split for every node that we have in cluster. And the job is just checking the divisibility, and it sends the result back. and the task just collects the results from the task from the jobs and returns the sum back. So here we are using capabilities of compute grid and cache operation because we write results into cache, and there is also persistence used here. So we have work related to CPU, network, and disk. Let's start the example. And now we can see that the node is starting, and now the work of the example started, and we already have some results. So let's now go to the web console and see what we have here. So we see that the cache metrics started to grow, and there is CPU consumption, and some heap size increased a bit, and we can see what is the latency of operations and how many records we have in cache. Also, we have metrics related to disk. Now we can see that 2 gigabytes is used for write-ahead log, and there is some other disk-related like partitions occupy some disk space. Also, we can see a list of nodes available and statistics of memory usage per data region. We can see how much data is occupied by each node per data region. And also there are statistics for cache. Other things are not configured here, so I'll not review them. Let's go to baseline topology tab. Here you can see a set of nodes that are inside the baseline topology, and you can see their status and ID. Here you can perform management on the cluster. For example, we may, for example, decide to kill one of the nodes, and it will be let out of the topology, and you will see it in WebConsole that the node went offline. And if we don't expect this node to come back soon, we may remove it from the baseline topology, and after that the data will be rebalanced, and the baseline topology will consist of only 2 nodes, the second and third one. So you may perform this kind of management in the baseline topology tab. Other tabs are related to GridGain enterprise features. So let's move to run update. This is a feature that allows you to have nodes of different versions in the same cluster, and usually the update happens in such a way that nodes are removed from cluster and replaced with nodes of newer versions one by one. And this tab shows you how many nodes are of a new version, if any rebalancing is happening on the cluster. So if you see that there's a rebalancing going, then you may want to wait for it to finish and to continue only when all the data is rebalanced. So this is a kind of a dashboard that lets you see information that is useful for performing rolling update. Other tabs are related to enterprise features. I didn't configure them. The data center application and snapshots. There is also management, a set of management tools which can be used, but well, in this particular cluster, there's no such features. So let's get back to slides and have overview what we have discussed. So you always need to know if you have enough resources, on the basic level. Like you would like to know if you have enough CPU, memory, disk, network, which is the main thing which is the basis for work of your application. So you would like to make sure that you have enough of these things. And for JVM, it's really important to have garbage collector logs available to distinguish the network issues from GC, and to identify when latency spikes are related, especially for GC logs, because this is a really common issue, and it can be easily tracked by just analyzing garbage collector logs. And of course, application logs have a lot of useful information, and you may you will always need it in case if anything goes wrong. Plus, if you know that there are any problematic places, for example, if you have not that reliable network, then you may want to configure additional monitoring for it in case if something goes wrong, to eliminate it from other kinds of issues. So now I'm ready to answer your questions. Here you can see a link to our WebConsole website and my email, and also you can find a Docker image of Elasticsearch, Logstash, and Kibana configured especially for Ignite. So you can just start a container and start monitoring your logs by using the same interface that I showed. Thank you.
Thank you, Dennis. I really like the link to the pre-configured. I guess that was, did you say that was Grafana as well?
Grafana, you mean, did I try using it?
No, I mean the pre-configured combination for monitoring you have down there, GitHub.
Oh, really? There is a pre-configured? No, I didn't.
Oh, no,
know
I
about
wasn't
that.
sure. I misheard what you said. But it's.
Oh, no. No, I don't have it pre-configured, but it would be really nice to have something like that. So if anybody on the webinar has something like that, let us know.
Got it. Okay. Yep. I'm looking forward to it too. So first question, I'm going to go pretty much in order, the way they came in. Someone asked about exporting from Ignite into Prometheus, exporting the basically they called it a node exporter, but it's grabbing the data from the nodes in the cluster out to Prometheus. And if you can generalize it, that'd be great. What would be your approach for Prometheus, and then just in general for getting access to the monitoring information?
Yeah, I got the question. Yeah, usually if you want to expose metrics of Ignite to some external third-party system, then usually JMX is used for that. And for Prometheus, there's an exporter that can look at any application that has JMX and grab that metrics there and store them inside. And this is a pattern that can be used for any system that that supports a kind of an agent that collects metrics or some information about your system. So usually there is a kind of an agent that collects things and stores it back into storage.
Okay, and then in terms of getting access, there was another question which was related. You showed some classes, which I think were the JMX classes. How do you find out more about these classes? Because I'm not sure they're all documented.
There is the documentation in Java doc, so you can find what it what are the capabilities, and you can just go to you can just open this MX beans using some tools for reviewing, and they are like self-documented. You can find the description of MX beans. They are included into themselves, so you can see them in the tools. So by just looking at what's available, you can like decide what's suitable for you.
Okay, so if someone searches for the classes that you put up on the slide, they should probably be able to find something.
Yeah, there is JavaDoc, so you can look it up in JavaDoc, and also by just looking at what MX beans are exposed, you can see what's available for monitoring.
Okay, if you can't find it, then folks, you can probably post to the Ignite forum or to GridGain forums. That's forums.gridgain.com, and ask. And I bet someone will respond pretty quickly and give you the right links or some more information. My guess
if we have some documentation gap, then it's good to know if we have some missing information. So if you can't find something, then it's better to ask on forum. So we'll give you a link or document it and let you know about that.
Good. Okay, another question on GridGain Console. Someone was collecting data. They thought if the tab was not active, the data was quote unquote lost. I didn't think that was the case, but I was curious if you knew the exact mechanism, how it's collecting data, and then how console accesses and displays it.
How WebConsole collects information. Okay.
Yeah.
There is a web agent that sends requests to your cluster using REST, and there are tasks that are going around the cluster. And for example, if you want to know about cache size, then there is a task that is sent to all nodes, and local sizes are collected. And after that, the reducer node that started the request will sum the sizes and send the response back by REST. So there is communication between WebConsole and the web agent, which is installed next to your cluster, and the web agent talks to your cluster and it sends the task requests.
Okay, and how is the history kept?
Well, the history currently is kept only. It's kept only on WebConsole. So if you like restart the page, the plots will reset. We are working on improvement of that by we're changing the way how data is stored by re-implementing the mechanism of the web agent, so that we could store some information inside the cluster that we monitor. For example, we have this for SQL queries. There is a tab for SQL, so the queries that were run from WebConsole are recorded. But we are going also to implement it for storage of the metrics history.
Okay, so that's probably 2.8. Or it's coming in any case.
Well, I don't have like information when it's going to be implemented, but we're working on that.
Okay, so the short answer is keep it open until we fix, until we store.
Yes.
Someone's thinking about using Kubernetes, and I guess Docker and Kubernetes with Ignite in production. And not able to connect to the cluster. And is there any doc that helps? I think I know the answer to this question, but I'm curious what your answer is on connecting the Kubernetes. And so I don't know if you have recommendations for that or not.
So what is the question? Like how to
Well,
move
I think they're spinning
Kubernetes
up
to
WebConsole.
Kubernetes?
I think they're spinning up a Docker Kubernetes cluster and then spinning up WebConsole, and console may be outside of the cluster. I think that's the problem. Web console
Oh,
is
so
an
console is outside.
yeah,
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 so you need to expose the REST. Yeah, you need to expose the REST endpoint to outside and to make the web agent to connect to one of the nodes.
yeah,
I
and
think
so
something like that.
yeah, so A, they probably need to turn on the web agent within the cluster, and B, they need to open up. It's HTTP, the way the agent connects to console, right?
Yeah, basically.
Yeah,
Or
yeah.
you can install a web agent inside of Kubernetes next to your cluster and make sure that it has access to web console.
Yeah, I think one of the more common things I've heard with Kubernetes that people may miss is Kubernetes only has HTTP ingress, meaning you're not connecting with if you're going to run clients and nodes in a cluster, they all need to be within the Kubernetes cluster. It's probably the same thing with the web agent. You can only do HTTP ingress. So that may be the issue as well.
Oh, I see.
And then no, the Ignite cluster and WebConsole are in the same namespace. So it sounds like there's some other kind of issue. Again, my recommendation is go to the forum and post. And usually people are pretty good about helping you figure out your problem here. It is being run today. American Airlines has a pretty big Docker Kubernetes cluster running with persistence. So it's been done. It's probably some configuration issue, and someone will probably know how to solve it in the forum. Those are all the questions we had.